Hello, welcome everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs Stratton Energy Solutions. With me today is Nathan Heston, one of the other trainers. Hello, Nathan.
Good morning, Daniel. Good
Good
morning,
morning.
everyone. Thanks for joining us.
Yeah, thank you. So just a few things before we get started for housekeeping. This is going to be, it is being recorded, and we will send out the recording along with the copy of the slide decks to everybody tomorrow. Additionally, this course does have NABCEP continuing education credits available. So at the end of this presentation, my email is going to pop up. And please email us letting us know you want those credits, and we'll go ahead and issue them. Be sure to include your full name, spell it out for us so we know the exact name to put on the certificate. Additionally, we do encourage everyone to comment questions. We do have the Q&A feature. It's either at the top or the bottom of your screen. Chat is disabled, but the Q&A feature is open, and Nathan will be monitoring them as we go along. So a couple exciting events coming up. One of them is next week. Actually, both are next week. Nathan, where are you going to be headed to?
Yeah, I'm going to head to OSEA in Portland, Oregon. I'll be doing a training there on whole home backup. And so if you're in the Portland area for that conference, love to see you there.
Yeah, and I'll be out in Hawaii. I'm going to be at the Hawaii Solar Energy Association's Solar Expo. I'll be talking a little bit about introduction to our 6.6 battery, which we're going to talk about a little bit today. Also doing off-grid living, and just to remind everyone, our products are warranted for off-grid use. And then talking a little bit about communications between inverters and batteries. So if you are going to be at either of these events, please email us, let us know you'll be there, and we'll make sure we set aside some special swag for you. Well, let's go ahead and jump into it. One last thing I want to mention, though, before we get started into codes and standards is some promotions. Right now, we do have $1,000 off your first install. You don't have to be part of the Elite IQ Installer program. If you do happen to join the IQ Installer program, we're additionally going to give you $100 off each battery. So up to $1,300 on your first install with a stack of 3 6.6 batteries. There's a QR code on your screen. Go ahead and scan that. In addition to money back, we'll promote you, put you on our maps, and we usually have rotating programs for rebates. So this is a great opportunity. Get some money back on your first install. Get yourself promoted as well.
And that $100 back, Daniel, that's not just on your first battery. We do that for every battery that you install throughout the year. So every battery module you put in, we give you $100 back on at the end of each quarter. So joining our IQ program, can certainly get leads for you, but it can also pay you back at the end of the quarters.
Yeah, that's a great point. $100 indefinitely, as long as that program runs, which it usually does, or we change it to something else. Another opportunity, this is one directed at your customers, really to help you close some deals. Now, we do have an upcoming how to sell energy storage talk, and we'll get a little more into that. But right now, we're offering some gift cards. So if you got a customer that's on the fence and you got some quotes out there, you can offer these gift cards to your customers, and you can fill it out for them as the installer, or the homeowner can fill it out. There is a QR code. This is going to be ending soon, so it's timely to get it going. So really quickly on our agenda, we're going to talk about why codes and standards matter, the risks associated with energy storage systems, how these all came about, and we're going to talk about NFPA 855. This is a standard that informs a lot of the building codes that have been adopted. In the talk with some review of some of our products, and then make sure, again, leave some time for Q&A, but I encourage everybody to use the Q&A chat feature or Q&A button to add in some questions as we go. Some of the content that I developed this course from was from California Solar and Storage Association. So if you're here in California and you're not a member, I encourage you to join that. And if you're in a different state, I encourage you to join your local solar storage association, because they do a lot of great work. Mayfield Renewables has a lot of great learning content that I used, as well as John Cromer from SolarArc has done a couple of talks on this topic that I kind of reference as we go along. One thing, Nathan, you're a member of this, right?
Yes, I am. I do have a membership with NFPA Link. And in fact, John Cromer had recommended me to sign up for this. And the great thing about this is that you have a searchable database of the codes and standards that Daniel's going to be referring to today. So having access to the NFPA 855, but it's not just the code, it's actually explanation of the code as well. So this is a very valuable resource, and it's well worth it. I think it's even discounted if you do a recurring payment. So it's a good value, and I'm glad you put this slide in here for those that are considering having access to the code.
Yeah, and you hit it though, Nathan. Talking about the supporting content or the explanations is what really helps out a lot. So one thing I was excited about is batteries are not new to Briggs and Stratton Energy Solutions. Way back when in the 1980s, we actually made one of the very first hybrid cars in the industry.
1973,
Yeah,
during the
yeah,
gas crisis. Yes,
yeah,
Briggs and Stratton.
and there's a great YouTube video, Jay Leno's Garage. I don't know if anybody's has watched that. He actually drives the car. It wasn't that we were gonna start making cars, that we wanted to show the example of how we can start to save fuel using some of our smaller engines. So it's
So
been
Daniel, I
some,
got to
yeah.
see this hybrid car from the 1970s, over 50 years ago now. So I got to see this hybrid car recently. And what's the kind of biggest difference between that and maybe say a Prius that you noticed on the car?
Well, a third axle,
Yes,
because
you have
back
two
then they
axles in the back.
I think that speaks, Nathan, to a little bit about how relatively new lithium ion, whether it's NMC or LFP or the other chemistries, are. Right back then, all we had was lead acid batteries. So they added this third axle to support all these lead acid batteries in the back. But definitely, Briggs and Stratton Energy Solutions has evolved along the years, and they acquired Simplified Power about 3 years ago. Simplified Power has been doing these energy storage systems for over 10 years now. And so we're definitely experts in all things energy storage, not only for your home, like you see now, but also for upcoming lawnmowers. And Nathan and you and I had an opportunity to go out to ride one of our electric zero-turn lawnmowers. So we really have the capability as a company to do cell batch testing, to have R&D facilities, to have a truly global infrastructure to help support these renewable energy batteries, not only for the solar industry, but also for lawnmowers and the such as well. And really excited to be talking about our 6.6 battery today. Well, let's get into the topic, codes and standards for energy storage systems. So really the goal of these things is to reduce the likelihood of a fire, right? Property damage. But I would say the most crucial one is to reduce personal injury. What we're doing, and I just mentioned it, energy storage systems are relatively new, and we're starting to put these very energy dense batteries on people's homes and people's businesses. And there's a lot of concern from the first responders, from insurance companies, frankly, from the manufacturers themselves, that we're doing this in a safe way. So a lot of these new codes and standards are now just coming out. And it's kind of almost a little Wild West on who's adopting these, what code cycles they're adopting them on. So I hope today to give a little insight to that. Usually these codes and standards typically lag a little bit behind the technology. And they're trying to implement these codes and standards in a kind of a science-based manner, where there's labs, there's code making panels that are looking carefully at these, because these codes and standards do have an impact on how we as manufacturers come to the market. For example, if they say the maximum is 20 kilowatt hours per storage unit, right? As manufacturers, we're going to design them to fit these 20 kilowatt hour blocks. And then, of course, if they say there's ways to increase those by following different standards or following commercial standards. So it is really crucial. These codes and standards that are coming out influence the way we as manufacturers come to the market.
And the field is evolving, Daniel, and I appreciated you saying that, right? So it's important that as battery technology evolves, that codes and standards are there to protect customers, to protect businesses, to protect personal property. Safety is a major one. And I highlight that you're going to talk about UL to some extent today. But there's also a national battery fire testing laboratory in Los Alamos, New Mexico, that has done a lot of this testing that influences the codes and standards and where we are going with those codes and standards. You mentioned lags, and just like the National Electric Code, there are years, right, of code publication, and those cycles are typically 3 years. Right. So I'm going to let you get into it, but it is an evolving field, and that's one more reason why I think CodeLink is a valuable subscription service to sign up for.
Yeah, absolutely. And I think you kind of hinted at it, Nathan, that it takes the collaboration between all of the industry partners to make sure we're evolving this energy storage industry in a safe, responsible manner. And one of the biggest things that kind of prompted a lot of this really closer examination was that APS fire you see a picture of there. So what causes a battery to fail, right? So it can be from the manufacturing of it, defects or design or installation errors. That would be more of an installer mistake, but it can be caused by cells not being constructed correctly. It could be mechanical abuse, right? And so we're going to talk about why you might need a parking bollard, or you might need to mount an energy storage system in a garage that's not in the path of a vehicle, right? Because if somebody crashes into it, it could potentially damage cells and cause short circuits in the cells. So that's one way. Thermal abuse, right? If you're being exposed to heating sources, I'm thinking if the house is on fire, not because of the energy storage system, and that fire then propagates to a place where the energy storage system is and heats that battery up. Electrical abuse, right? So that's the idea that if you, for whatever reason, you don't have the inverter or the charge controller operating the way it should, you could overcharge the battery or potentially discharge the battery too quickly, which could cause the batteries to fail. Additionally, an earthquake or perhaps a rodent damage as well. Floods, I saw a picture, Nathan, with some of those floods out on the East Coast where during the hurricanes, where somebody had an electric car in their garage and the floodwaters came up and caused that battery to fail. So absolutely, there's a lot of external factors, and some of these codes and standards are here to help mitigate some of these things.
And some of these safety practices have to do with smaller devices. You mentioned a car fire. Most of those batteries are sealed, right? But but even scooters and electric bicycles, we have to be careful about in some of these situations, right? I know I have a hoverboard, one of those little electric hoverboards in my garage. So if I were to flood, that's down near the ground. And so these are new things to think about as technology evolves. Briggs & Stratton has long been known, 115 years as an engine manufacturer, and we have a lot of common knowledge now, to us, common sense knowledge around gasoline and how to deal with our engines. Well, I think there's going to be some amount of education that happens with battery safety.
That's a good point. Yeah, and I'll also argue with engines, there's a lot of concern around the exhaust. And so we're very careful to talk about in some of our generator trainings, which is available on the Power Academy. I'll share a link to that a little bit later about where we position, how far away from vents it's 3 feet. To be able to not poison the homeowners with carbon monoxide. So what can happen when some of these batteries fail? One of the kind of words you hear a lot is called thermal runaway. That's when a cell is either shorted out or it's heated in such a manner that it starts to go into a thermal runaway, which it's a chemical reaction, so it doesn't necessarily need external oxygen to get it going. And then that heat of that individual cell is then propagates out to adjacent cells. And then you get this kind of like chain reaction where it goes cell to cell and potentially even battery module to battery module. And it just kind of goes on this thermal runaway. Now, we will talk a little bit about how some of the chemistry does matter on this. And LFP with lithium iron phosphate, which is what we use in the stationary home batteries, has less likely to go into that thermal runaway event. But it absolutely can be a concern, and nobody out there can say that their cell won't go into a thermal runaway, and I'll talk about that here in a minute. Stranded energy, so that's kind of a little bit of a concern, right? So even after a fire, the batteries themselves still may have some residual charge in that, and so how do we safely discharge the battery as well? toxic flammable gases generated. So when these cells do go into a thermal runaway event, they usually have vents on them that will vent some of this gas. And this can be toxic or flammable gas. And so we're going to kind of get into it, but there's talk of 9540B, a large scale fire testing. So what they want to do is essentially ignite some of this gas. So definitely thinking about how these gases vent, what's the composition and the quantity of the gases being vented. And last thing, when these batteries do go into a thermal runaway event and there's fire essentially inside of them, how do we extinguish them? I already mentioned earlier that it has all of the oxygen and everything it needs for that fire. So really the only way to put these things out is to cool them down with water. But when we have a battery in a metal case, perhaps in another metal case, inside of a cell, how do we really get water onto that hot spot? And that can be difficult in some of the designs here. So one of the biggest things I want to make sure we all kind of take away from today is the difference between codes and standards. So NFPA 855 is a standard, right? And that standard is then usually adopted kind of verbatim in codes. And for example, what we're going to do is talk about today is the California Residential Code. And specifically, we're going to look at one chapter in that, where if you look carefully at the NFPA 855, and if you have your NFPA link, you can go look at this. It essentially is just a kind of a copy paste of what's in these codes. Some of the other codes that your states may adopt, like the International Residential Code, again, look really carefully at the NFPA and take them verbatim, although there are some slight variations, and we'll talk about what some of those may be. So again,
so Daniel, I want to point out, to what you're saying right now. So the NFPA 855 gives a standard for safety in the installation of energy storage systems, and the code very much follows that standard. And you are going to be talking today specifically about California Residential Code, but the majority of the code around the country, if you're in a different state, is almost identical to what you're going to be talking about today. So it follows the 855 standard. And so there might be slight variations, as Daniel mentioned, specifically in terms of amount of battery capacity you can install, that kind of thing. And yes, we are going to be sending out copies of this presentation. So that was a question here in the chat asking if we'll get a copy of the presentation. Yes, everybody who has registered will get a copy of the slides. I'll send those out tomorrow, and you'll get a copy of a video recording of the presentation as well.
Yeah, thank you, Nathan. Absolutely. Great way to kind of break that down, that you're going to see this in your local codes if you're not happen to be in California. Lastly, a standard is not enforceable. A code is, right? A code is adopted by the jurisdiction or the state. And that when they adopt that is when it becomes enforceable as well. So kind of as Nathan mentioned, a lot of our states have all adopted the NEC, or the National Electric Code, is for the electrical code standards. But where we're kind of going to get in today is building codes. And so most states base their building codes on this NFPA 855, specifically to energy storage systems. So when you start to look at these, there's the International Residential Code, which is kind of specific to residents. The International Fire Code is more on commercial. So we don't have time today to get into the commercial side, so we're going to stick to the residential side as well. But also keep in mind, that the residential inspector, or when you go to the permit plan desk at your local jurisdiction, right, they're going to enforce the International Residential Code when you're looking at a house as well. So there are other I codes that I just kind of hinted at: the International Building Code, the International Fire Code. Again, we're going to look kind of specifically at the International Residential Code. And some states haven't adopted their own kind of California or their state-based codes. They just kind of adopt the International Residential Code. And so you're going to see again that the NFPA 855 is kind of copied almost verbatim in these international residential codes. But keep in mind that often they adjust that to meet the unique needs of their jurisdiction as well. So NFPA 855, really, they're around a lot longer than I thought, almost a little bit longer than Briggs Stratton has been around, Nathan. but really they're out there to help keep you and your neighborhoods and your homes and your businesses, specifically people, safe, right? As Nathan mentioned, they are also on a third-year cycle as well. And I would say that this NFPA 855 is relatively new, right? 2019 was the first time it was released. And
yes, for clarification, the National Fire Protection Authority has been around since 1897. The codes, the standards for installing batteries has been around for about 5 years.
yeah, and so I think it just speaks to how fast and how new all of this industry is. And as all of us are out there every day putting more and more energy storage systems on homes, that we do it in a safe, responsible manner as well. So what we're going to do today is kind of look at the California one, like I mentioned, but Chapter 15 of the 855 is where we specifically get into the residential sector and to define what a residence is. It's a one or two family dwelling or townhouse, and it says specifically that that's what you have to apply to, and you don't have to start considering some of the other commercial codes, which can get really expensive if you start to have put in fire doors or sprinkler systems and retrofitting systems. So again, NFPA is both the electrical code, the NFPA 1 and NFPA 855. So there's a lot of correlation between these documents. 9540A, that is a UL listing, and we're going to look at it that in order to comply with the 855, you do have to have UL 9540, which is a safety standard for energy storage systems. And in order to get your 9540, you have to go through 9540A, which is essentially a way to force battery cells into a thermal runaway, and then you watch what happens. And I will say this, that with LFP chemistry, specifically in our batteries, not a lot happens. Of course, we didn't pass the cell level test, so we jumped up to the module level test. But we were able to stop there and not have to proceed to the unit level testing because we didn't show that kind of thermal runaway that spread through the whole battery pack. We got the adjacent cell to go, which is what you need to have a valid test. It's not a pass or fail. It's really informing what needs to be called out in your 9540. And we do have other talks where we jump a little bit more into that. One big thing that just came out, and I don't know if anybody attended this, Mayfield Renewables recently had their education summit. So I'd love to hear if anybody in this talk actually had an opportunity to attend. Please put that into the Q&A, what you thought if you were able to attend. But this was a big topic. So this is being proposed. It's not out yet, but it's not going to replace 9540A. It's going to be in addition to 9540A. And really what they're trying to look at is, yes, these things off gas, what's the composition and what happens, but they want to actively ignite this stuff. So there's a great video that UL released, and the link is down in there in the bottom right corner if you guys want to take a look at it. But what they do is they kind of replicate a lot what we do in the 9540, but then what they do is, it's a little hard to see, but you might be able to see these little wires here. What they do is they kind of wrap the battery, the energy storage system with these ignition sources, typically where they expect the vent gases to come out, and then they're actively igniting the gas that's emanating from the energy storage system when it's in a thermal runaway event. And then they want to see what happens, right? This is going to dictate how far or close you can space the batteries, whether or not you need any fireproofing material in the room. So again, and that I think goes to that APS fire, is that the first responders would rather have something on fire than a room filled with gas that could combust, right? Because that creates this explosion hazard. So there's a lot of talk about this coming along. And I really think that it's going to take, again, all the stakeholders to make sure that when this comes and is implemented, that we do it in a science-based, non-discriminatory manner that's really looking at what can happen with these systems. So keep an eye out, a lot more kind of coming out when this news, and so we'll keep you up to date. And you can see how they kind of have that initiating battery energy storage system with the igniters essentially positioned around the battery. Nathan, anything to add?
How do you feel about some of these? I mean, the point of these tests are to make sure that, if you have a battery go into a thermal runaway event for any situation, right? There's a wildfire that causes the outside of the building to get very hot, right? Or the teenager pushes the gas pedal instead of the brake on the car, or a battery gets dropped during the installation process. That that the fire that might result from one battery going up is not going to propagate to the batteries around it and is not going to lead to an unsafe condition in which the room builds up with electrolyte gases, as Daniel's mentioned. So the idea here is to make sure that we are keeping the customer, the homeowner, the property as safe as possible. And so we're going to get into the idea with today's talk is to talk about how to install in very, you know, in the most progressive and safe manner possible that follows this code, which is informed by these safety tests.
Thank you, Nathan. I'm not going to run through this entire slide, but this was a great slide that I attended one of Ryan Mayfield's trainings where I kind of was able to look at one of the slides and then I kind of recreated it. But this is a great reference. So if you've got your code book out, you know which code article to go to specific to these scenarios on the left. Again, everybody's going to get a copy of this. So let's jump into the California residential code. Specifically, we're going to go to section R328. And we're going to look at that. So again, a lot of people base their electrical codes. The California electrical code is just based on the NEC. The building code is based on the international building code. That's kind of more commercial as well. But what we're going to do is jump into the California residential code. Most states have adopted these, but with some alterations, and we're going to take a look at that really quick. So in chapter 3 is where we find the section on energy storage systems. And California adopted these back in January 2023. But again, just keep in mind that even though we're here, we need to still follow the electrical code as we're going forward. So really what we're jumping into this very first one is kind of what I was hinting at first. Energy storage systems shall comply with the provisions. Now, I'm going to do my best, Nathan and everybody, not to read all of these, but I did want to include the actual language out of these code sections here. What this first one is saying is really it needs to be 9540 unless you can mark it as suitable for residential dwellings. And at this point, nobody has actually had a cell that has passed at the cell level test, which would show that there's no possibility of it ever going into a thermal runaway. So when they say,
in other words,
yes,
right, all of our batteries are built with cells which contain electrolyte. And if you intentionally heat those cells, they will off gas. And that gas that comes out from the electrolyte is flammable. So all of our lithium batteries, there's plenty of talk about solid state batteries, but we're not there yet. And all companies manufacture with electrolyte right now.
Yeah, that's a great point. All of us is the whole industry at this point. You know, they say for use in residential dwellings, really that specific or that special battery that can't go into thermal runaway should say, you know, habitable spaces, because you can put our batteries and a lot of other manufacturers' batteries on residential dwellings. You just can't put them in habitable spaces as well. So another section here is just talking about if it's less than 1 kilowatt hour, you don't have to abide by all the rules we're about to go through as well. So you do need to have the 9540 listing on that. One thing is kind of interesting, and I know that we have a very robust kind of industry where there's a lot of EV batteries, but apparently repurposed EV batteries do not need to be listed to that 9540 as well, as long as you kind of keep them away from the property 5 feet away.
So Daniel, I mean, to the point that you just made, any battery that is installed in California shall have, and shall means is required by code to have 9540. That doesn't mean that batteries, you know, come in and don't get installed that don't have the 9540. In other words, we know that installations happen that don't have the 9540. However, we always want our batteries to be code compliant. All of our batteries have UL 9540 and are therefore certified for installation in California or other locations, as Daniel said, throughout the country that have adopted the International Residential Code, which requires 9540. So yes, we know there are a lot of batteries that are kind of coming in from overseas that don't have 9540. as an installer, an installation company, you do not want the liability of installing something that does not meet the code.
Yep, exactly. And yeah, the one caveat, right, is it's less than 1 kWh, or if you repurpose some EVs and you keep it 5 feet away from the house. But yeah, I don't, that's going to be very rare. And a lot of the 1 kWh, those are more the, I'm thinking the little power packs that you have as well. So please don't use the installation manual as a knee pad when you're installing our batteries. Be sure you read it and you understand it, because when we as manufacturers have to get our UL 9540, we actually have to send in copies of our installation manuals, and they vet those. So you need to follow the protocols that are called out in our installation manuals. So one thing keep in mind is that you have to keep batteries 3 feet apart. Um, unless you have that large scale fire testing as well. And so there's a lot of and we talked about that with 9540B, is that even if you do have a 9540A and you do have it called out that you can do closer than 3 feet of separation, a lot of jurisdictions don't care, and they're still going to make you space it 3 feet apart. So that's kind of where this 9540B is going to kind of step up, is the jurisdictions like San Jose, California, like other ones. They say, we don't care if your 9540A says you can go closer than 3 feet. You still need to do that. And the 9540B is what they're going to start asking for if you want to start to close those separations a little bit closer. But in this section here, R328.3.1 is the individual battery units need to be 3 feet apart.
And let's spell out what an individual battery unit is. There's a
Yeah.
limitation of 20 kilowatt hours on a battery unit. So for instance, with some of our newer batteries, it's a stack of 3 modules, right? And it's units of less than 20 kilowatt hours, unless 9540A allows reduced spacing.
Yeah, and there are some also 9540A that might allow you a larger than 20 kilowatt hours. But again, we get a lot of jurisdictions that are pushing back. So it causes us in the industry as manufacturers to design to some of these set points that we see called out in the codes. I can't stop talking about Ryan Mayfield today, but this was a great image that he had done, and Kate Francis had created here, where it's showing kind of the 3 feet separation, 3 feet from doors and windows. And then additionally, it's talking about the maximum amount of aggregate installation you can have, right? So 80 kilowatt hours on an exterior, 40 kilowatt hours in a utility closet or a utility space or a basement as well. And you can do 80 kilowatt hours in a garage. Now, California has recently upped some of these, and I'm going to show you a slide here in a second that talks about how those are bumped up.
Before you do, Daniel, I
Go
just
ahead,
want to
Nathan.
highlight this slide. This is probably the most common violation that we see of code, and that is going within 3 feet of a window that leads to a habitable space. So you could be within 3 feet of a window that leads into the garage, but
Yeah.
you should not be within 3 feet of a window that leads into a living room or a bedroom. And we see this fairly often. You have to be 3 feet from windows and doors when installing on the outside of a house. And so that's one of those violations. And then the other one would be, installing at the back of a garage, you do need parking ballards unless you're up 36 inches off the ground. Actually, I might have that height off.
I have it coming up. No, I got
Okay,
it coming up. Yeah.
and then the option in a garage, the best option in a garage is probably to put it where it's not sticking out more than
Yeah, right
wing
over
walls
here.
as well. So Daniel's going to get into all of these, but I wanted to point out that 3 feet from windows and doors is a violation we often see.
And I get it, right? Because you're out at a house and you got a spot for the energy storage system, and there's a window there. I mean, it's right next to the main service panel. It's going to make pulling wires easy. It's going to make it so the homeowner, although we have a great looking battery, they don't want it necessarily in the front of their house. So I get it. The challenge is when we're actually in these real world installs, trying to find a place to put these batteries. But
Well,
again,
I've got an
yeah.
example. So yeah, you choose the easy spot to put it, and then I've got an example where somebody's just had to go out and move the entire system because they didn't follow code and the inspector won't sign off on it. So it is really important that you choose an appropriate location so that you don't have to relocate that system.
Yeah, yeah, that's absolutely correct, Nathan. Thank you. So again, where can we put these things? I guess the big takeaway is you can't put it in a habitable space. You can't put it in a garage, a detached garage. A lot of garages that are attached already have drywall between the garage and the living space. And if you do have that, you're good to go. There's a lot of talk about having to put drywall in, right? So if you do have a garage that's unfinished, but does have drywall between the living space in the garage, you don't have to drywall the entire garage. And I've seen code inspectors kind of misinterpret this a lot. If you do come into like a utility closet or perhaps a basement that is unfinished, you are going to have to drywall it. But if it already is drywalled, you're good to go. You're not going to have to come back and add, extra thick 5/8 inch drywall on this. So again, understanding this is really crucial, because if you go install an energy storage system and then all of a sudden you find out you have to move it, or you have to drywall the room that it's in, that's a lot of money that you probably didn't have in the quote or the home improvement contractor that you have with the homeowner. That's going to be a tough conversation. So understanding these ahead of time, and I got some other tips and tricks to understand those coming up here in a minute, is really important. But you cannot put these in sleeping rooms, closets that have an entry into a living space. Although I have had a little bit where they let you put it into a utility closet if it has a door to the outside as well as a door to the inside. But always have a good relationship with your code inspector. Make sure when they're approving your permit plan sets that you call out where these things are going and that they're looking at these things carefully as well. Can't be more clear about it. 3 feet from doors and windows. Garage windows are okay as well. So this is where Nathan was talking about a little bit earlier. Individual energy storage units shall be 20 kilowatt hours or less. And then you can get those a little bit bigger, but then you have to start jumping into some of the commercial code. And then there's some aggregate quantities that are the total. So if each unit is 20 kilowatt hours, right, you can then have a certain amount in certain spots, right? Like utility closets, basements, that's 40. And then on the outside of the building or inside or all the places combined is 600. And that's specific to California. And I got a great slide here coming up that kind of calls out that a little bit.
Yeah, and Daniel, I mean, oftentimes this is interpreted by UL to be a maximum of 80 kilowatt hours total in other locations, right? And so California allows up to 600 kilowatt hours. The 80 is actually a specific location.
Yep.
But I'm just noting here that that 600, as Daniel mentioned, is an aggregate on the property in California residential code that might be different in your state.
Yeah, and this was really recent. This was in July of this year, so they had upped it a little bit, right? So we're still sticking with 40 in a basement or a utility closet, 80 in that garage, as we talked about. But what's interesting now is in this new California one that they now have a difference between exterior, right? So you can have it on an exterior wall, and you can go up to 100. But if those exterior walls are non-combustible, and that's always an interesting, what's the definition of non-combustible, right? I would brick, stucco, perhaps, vinyl siding, maybe not, but who defines that is your AHJ? You can go up to 200 now. In a detached garage or a detached structure, you can go 200. And again, with everything combined, you can go up to 600, right? Is the maximum aggregate. One thing to keep in mind, though, is if you do have it on the ground, right, you got to have it 10 feet away from property lines or dwellings as well. You got to follow the electrical code when you install these things. And there was that great slide earlier in the talk that Mayfield Renewables had put together about where to find certain sections in the code book to make sure you comply with everything here. Additionally, the inverters, and almost all of them are now, are Rule 21 compliant, which talks about how the inverters interact with the grid. And there's UL 1741, SB, SA, also talk a little bit about how the inverters, and almost all of them have this now, how these inverters are going to interact with the grid, be a benefit to the grid rather than a detriment, by helping to maintain the voltage and the frequency of the grid.
So Daniel, we've got a couple of questions that have come in. So Aaron asks, even some batteries listed 9540 state to be installed per electrical code. So how does this apply when the code states to be installed per manufacturer specifications? If you don't mind, I'll take a stab at that.
Yeah.
So Aaron, when a manufacturer makes a battery, they will often make specifications how that battery is supposed to be installed, where it can be installed, what kind of clearances you need between that battery and other electrical equipment, for example. So the per manufacturer specifications part means you need to meet the requirements of that manual. And as Daniel mentioned earlier, the installation manual is sent to UL during the UL 9540 process. So it's basically UL stating that you have to follow the manual that the manufacturer gives. Jean-Pierre says, I installed outside. I'm not sure that I get this English properly, but can it go to weather at -20? I do believe we're talking probably -20 Celsius here. So I'm trying to understand exactly, Jean-Pierre, what the temperature we're looking at. I will specify that our latest battery, the 6.6 stackable batteries, will go from, I know it's 14 Fahrenheit for charging, all the way up to 50. So 50 Celsius, I think, is 132 Fahrenheit. And then on the Celsius range, is it -10 Celsius, Daniel, for charging
I
up
believe
to
so, yeah.
50 Celsius? And then on the discharging side, that temperature range is even greater. It goes to, I think it's -20 Celsius to 55 Celsius for discharging. So hopefully that answers your question. Yes, we do have a larger temperature range on our 6.6 batteries than most of our competitors. I do note that the charging rate slows down a little bit to a 5-hour charge window when you're in that colder temperature range below 32.
Yeah, and I think that's a great point because as we keep going through these NFPA 55 standards that have been adopted in the California Residential Code, you're going to realize that, hey, it's easier just to put these batteries outside, and realizing that not only our batteries, but most batteries, in fact, all lithium ion batteries, do have limitations in cold weather due to charging. So there are heating options, which we offer. Those are less efficient. And what Nathan has hinted at is that our batteries can go colder without needing those heating options. But it is, I think we're being forced in a lot of ways to put batteries outside. For example, like if we do put it in a garage, we have to have a heat detector, not a smoke detector, right? Because smoke detectors aren't rated to go into garages. You have to have a heat detector. And additionally, those heat detectors have to be interconnected with the other alarms in the premise. And there is also a little bit of pushback from California Solar and Storage Association about how some of these heat detectors actually aren't authorized to be in garages as well, right? So these heat detectors, and the detector is one that kind of operates independently, or it operates in conjunction with a central alarm system, whereas heat alarm can be its kind of standalone device that can communicate with other heat alarms or smoke detectors in the home. But it measures it on temperature rise. And also if the temperature reaches a certain degree, for example, 135 degrees Fahrenheit, well, some garages get that hot. And so now you're going to have the heat alarm or heat detector sounding. So there's a lot of concern, and there are California Solar and Storage Associations trying to have some of these rewritten. But again, these are the kind of things that you have to keep in mind when we're doing an install. So there's a couple of examples of Residio and Honeywell that make some, what we find, I think, are some of the best ones on the market to be able to add heat detectors or heat alarms inside garages.
And keep in mind, these are, so I did just I installed a carbon monoxide and 3 smoke detectors yesterday for somebody. They are in the same section. If you're at I was at a Home Depot, if you're a Lowe's or a Home Depot, they do have sections there for a heat detector versus the smoke detectors. I also note that they've gotten much more expensive than they used to be.
Yeah. Yeah, and there are these 10-year batteries in them now, so you don't have to change out the AA batteries. That's where I noticed they're expensive. Um, there's a lot of text in this one. This is kind of getting into the parking bollards and where you can put these energy storage systems in such a way that you don't have to install parking bollards. That's your exception down there, Nathan. So if the garage door isn't a very tall garage door, you can put it above 36 inches above, and you don't have to worry about some of this. But when we think, and there's a lot to interpret here, so I actually have a great kind of picture here that talks about that coming up here in a second. One of the changes is that they kind of went from a prescriptive approach where they're, instead of calling out certain mitigation strategies, they're just saying essentially anything that can protect it, a parking bollard, resist a 2,000-pound impact. And they're talking about exactly how to do this, right? The Schedule 80, or having a curb stop as well are allowed to be used. So I think this is the great way to kind of interpret this. And this is what, Nathan, you had been talking about, how we can install energy storage systems on the sidewall. And a lot of times I've noticed that this is where the service is, with usually the service entrance. So by placing the energy storage system over in the corner of the garage, next to where that is, that's going to minimize cable runs and save you a little bit of money on that install.
Yeah, and with those wing walls sticking out, the return wall there, leading towards that garage door, it does give you some space. Now you can't stick a very deep battery there, but all of our batteries can normally fit um, protected by that return wall, and then you don't have to worry about vehicle impact. So it's a nice location to put it, and then you're allowed up to 80 kilowatt hours in that garage along those walls.
Yep.
Note that without a wing wall on the left side there, that you do need parking ballards. And then in the very front of the garage where you could drive into it, you would need a parking ballard, or as Daniel mentioned, the curb is an alternative way where you wouldn't have a post in the middle of your garage. And that curb, I think, has to be, is it 42 inches? 54 inches.
54, yeah. And as a homeowner, I would probably want the parking bollard. I don't know if I'd want a curb stop right in the middle of my garage. One thing I don't see a lot of people doing is embedding these in concrete, right? This would be something you'd have to do during new construction, or jackhammer up the concrete and pour this. So I think what a lot of people are going to end up doing are these retrofit ones where you actually drill down into the concrete slab and then have concrete anchors that are then going to hold that post there as well. Ventilation. So this usually isn't a big concern anymore because lithium ion batteries don't produce flammable gases during normal charge cycles. Again, that's kind of different than what we were talking about earlier with the thermal runaway. Nathan, I thought this was kind of cool just to see how far we've come with these energy storage systems, is how dense they are, right? On the left, there are some, I think those are L16s, right? Some Trojan L16s, 6 volt, right? And I had
Yeah,
to
you're
put,
comparing the usable capacity there of all of those 16, no, 12 batteries. Yeah, it looks like 12 batteries there. The usable capacity, because you couldn't get the depth of discharge you can get with with larger batteries now. And so we're looking on the right, and these lithium batteries, although much smaller overall footprint in your garage, can store that same amount of capacity.
yeah, and even to keep it fair, Nathan, I kept it an
Almost,
80%
yeah.
depth. I kept it an 80% depth of discharge on that 6.6. That's our new stacking battery. But in a lot of applications, you can go down to 100% depth of discharge and still get a lot of cycle life out of that. So just a kind of indication, and also the ability to charge or discharge the batteries, right? Those L16s will probably C over 20, C over 10 if you're hurting them, whereas we can do 1C on ours. I'm going to keep going because we're still kind of running up on the top of the hour here. This kind of code section here is just talking about how an electric vehicle can be parked in the garage. So I'm now parking my Tesla in my garage, which might be 100 kilowatt hours. And so they're, again, talking a little bit about how make sure building departments don't start to treat electric vehicles as ESS. I know there's a lot of talk about vehicle to grid, vehicle to home. And there is a lot of talk around that. It's not quite there, but I do see that becoming a thing. So it'll be interesting to see how these codes develop as we go along. And we'll keep it going. I always thought that this was a great thing, that you should always have a label or a sticker on it, whether it's a water heater, a furnace, a garbage disposal, or an energy storage system, that you have a label of who installed it. So if there is a problem, they're going to call you. I think it's a great way. If you have the neighbors come over and look at it, they're going to see who did it, and you can earn referrals for that. But it's in the code now. You got to have your label. Additionally, we would always put like a little file folder hanging that would have a copy of all the manual and instructions kind of located there. So if somebody needed to service it, they have all that stuff right there as well. Stickers is definitely, so the labeling, right, is your manufacturer's labels. But there's a PV labels, and the alike are making a fortune on us, because a lot of these jurisdictions are now looking for these labels on parts and pieces of the energy storage system. So PV Labels is a great company that provides a lot of these stickers that meet some of these requirements. But there's a lot of confusion, I would say. I would always sticker up my systems as best I could. And then if the inspector gets there and starts asking for more stickers, I have them in the van ready to go, and I can add as many as they might like. Again, during energy storage systems, they don't release toxic gases during normal use. This, I think, is going to be the clearest way to avoid confusion and avoid mistakes. A lot of the jurisdictions in your area are going to have these like checklists, right? So essentially, get this ahead of time, look through this, and then this is going to call out exactly what they are looking for. And by understanding these, you're not going to have to kind of pull apart the entire code section. You're just going to look at these, understand what they're looking for, and check off the boxes. And that's going to make a really simple way to understand what individual AHJs are looking for. So this one's from the city of Berkeley in California. And again, I kind of highlighted the residential, but then it's showing the electrical code requirements as well. It's a really way to avoid confusion and having to go back. So Nathan, we got a few minutes left. So thank you everyone for kind of learning and sitting through that. We do want to share some exciting things. One of our most exciting new products is our stacking 6.6 battery. Each one of these modules is 6.6 kilowatt hours. They stack together relatively quickly, and being 6.6, they come just under that 20 kilowatt hour threshold is here. What we're seeing here is it paired up with SolarArc. We love that inverter. It's a great inverter, but we also definitely do have other integrations along the line. I will show here in a few minutes also our Phi and Amplify batteries. The Phi battery is a non-communicating battery, so that you can use that with the old tried and true trace inverters or Xantrax or Morningstars and the like.
Well, and you could even use the 6.6 battery with those older inverters, as long as you have the appropriate set points that are spelled out in the manual. So you can use this as a non-communicating battery. And this battery, you know, one of the nice features is how quickly it stacks. I mean, you said quickly. It is very quick. Even a real installation of this battery, getting it up on a wall mount, should be a 30-minute process for most installers.
It saves bus bars and really thick cabling, so it's all
no
of it
bus
stacks
bars,
together.
no making of the battery cables. You just have those home runs going from the battery controller to the inverter. All the communications wires from module to module are done through the Rapid Stack connector. And so really it's just those home runs from the Ethernet cable to the inverter, the battery cables to the inverter, and then connection to Energy Track for monitoring.
We still have those status LED lights, so it's still nice, I think, to have a little fuel gauge on the outside of the battery. So even if they don't want to get into the app, which is, you know, powerful and is going to show you a lot of the information, you kind of still get a visual. It's like going out to the Power Shack and looking at your Trimetrics battery meter. Maybe not quite as cool as the Trimetrics, but we still have those lights that will indicate the state of charge and whether it's in a charge or discharge.
Yeah, and keep in mind, this is an outdoor rated battery. And so like, unlike the LCD screens that'll burn out over time, you know, when exposed to direct sunlight, we don't have that issue with these LEDs. And And by flashing and doing other things, we can tell, the customer just by a quick glance, hey, this battery's in a state of charge. It's charging up. It's above 50%. It's heading towards 75. So a nice feature to it.
Yeah, the outdoor indoor app rating I think is great. I mean, put it in the garage. It's going to keep it in a kind of a more sealed environment, but it absolutely can go outdoor rated, and can go outside. It is wall mountable or floor mountable, so I think it looks great when it's wall mounted, but absolutely can do that floor mount, and it still looks great as well. These are some of the, we'll dive a little bit more into the specs. There's some of the temperature call outs, and I need to put in Celsius on this, but absolutely we can work at colder temperatures without needing those external heating options as well. The cycles, right? So at 100% depth of discharge, you're still getting 4,500 cycles. That's something like, I think 16 years, Nathan, or if 4,500 divided by 365.
Yeah, something like that. I don't know the exact number either.
And what's interesting, Nathan, is that I notice is that we used to always say, oh, 80% depth of discharge, and what I'm finding is that the depth of discharge matters for cycle life, but really also what dictates cycle life is the rate at which we charge or discharge. So we have two different charge and discharge rates there, right, Nathan?
Yes. Yep. So give me just a second, Daniel. I'm answering one of the questions.
Yeah. So
I'll let you continue this
yeah,
one.
of course. So 0.5 C is C over 2, and so essentially you can discharge the battery in 2 hours, or you could discharge 0.5. It essentially says you can discharge half the battery in 1 hour, and then 0.75, right, allows you maybe 3/4 of the battery in 1 hour. So it's really exciting to see that we still have a lot of cycle life on these batteries, even when leveraging the entire capacity of the batteries as well. LFP is still what we use. I will say this, that there is a time and place for some of these cobalt chemistries, specifically in those batteries that I was talking about with those riding lawnmowers. With cobalt, we want something that's lightweight, that's energy dense, that can be discharged relatively quickly, and that's where cobalt's going to come into play. And there's their own safety mitigations that come into that. But really, when we're talking about stationary storage, your home, your business, what we care about is cycle life and safety. And that's where, and we're scaling these up a lot larger as well. So we're still using LFP. We always have. We can stack these batteries up to create 3-stack module, which kind of speaks to the scalability of our batteries. Additionally, we can step them up to 6 stacks if you like to do that. Just under 120 kilowatt hours. We have put together some packages. I think this kind of takes out a lot of confusion with some of the homeowners when you have packages, good, better, best, and you can start with that. Of course, you can always add battery modules as you go along to increase the capacity as well. There's some of our legacy batteries. They're still absolutely great batteries. That one on the far left makes a great lead acid battery replacement. It doesn't have that. Yeah, Nathan.
So Daniel, sorry, I don't mean to interrupt, but we had a good question come in from an anonymous attendee. It says, on the exterior wall install graphic that showed the inverter in the 6.6, I believe, do you need an additional grounding rod within 6 feet of the inverter or the battery stack? For our batteries, because they are DC batteries, we do not need a grounding rod. I would defer to Daniel as to whether or not he knows whether or not we need an additional grounding rod for inverters. And I do believe that the answer is yes, but I'm not certain of that. Daniel, do you know?
I don't want to speculate. I do know this, that when you are installing energy storage system in the newer, replacing the service panel, you do have to have a grounding rod. You do have to bond water and gas, I believe. And you do have to add an additional ground rod, a second ground rod 6 feet away. So let's look into that, Nathan. Let's get some clarification. We'll get back to everybody on that. But grounding, I think, is one of the most common mistakes when it comes to the National Electrical Code. So if anybody in the Q&A has more clarification, please feel free to chime in. But yeah, we'll have to jump into that NEC code and look exactly where we're at.
And I do think that we should point out right now that the neutral ground bond for for a home should occur at the location of the service disconnect. providing additional grounding, you do not want to bond to neutral at the location of the inverter. So an additional ground rod would not hurt. The ground and neutral are preserved when the interconnection device switches from grid to battery, so that the neutral and ground are preserved, at least in North America. And so I think we're going to have to get back on as to whether or not we're required to install an additional grounding rod. It's a fairly easy thing to do, but I'm not certain. It sounds like Daniel isn't either, whether or not that's required with the inverter itself. With our batteries, it is not required.
Yeah, and there's equipment grounding, and then there's current carrying grounded conductors as well. So there's, again, it can definitely be a great conversation. We'll get back to you.
So Matt comments here, whether or not you install an extra ground rod might depend on whether the inverter is a transformer based or a transformerless inverter. So the SolarC is a transformerless inverter. I do believe what's the common 6848, Daniel, is that a Schneider inverter that is a transformer inverter, and so there might be a difference there. So we are at the end of the hour.
Yeah, if you need your NAPSEP, energy storage training at basco.com. Email energy storage training at BASCO, Briggs and Stratton Company is what that stands for. Email us. We will be sure to get over your NAPSEP credits. Again, everybody who attended is going to get a copy of the slide decks and a recording for this. Again, if you're going to be in Oregon or you're going to be out in Hawaii, let Nathan and I know, and we'll be happy to say hello. Nathan, any closing thoughts or anything else for us?
Well, if you are at the CALSA dinner tonight, this California Solar and Storage dinner tonight, make Daniel buy you a beer. So
yeah,
Daniel will be heading down there just after this talk right now. I do want to thank everybody for their time. If you have suggestions on how to make these trainings better, feel free to respond to the survey, which will be linked in the email I send out with a recording and the slide deck. Thank you,
Nathan.